In this segment, we'll go ahead and present some thoughts about simulation settings. When you begin to develop your model, you want to think about the time frame over which the model is intended to present the implications of the interactions or the relationships that are part of the model. And it's typically very easy to determine whether or not we're talking about something that happens in terms of minutes or hours, days, weeks, months, or years. I mean, if you're talking about filling a bathtub, you definitely don't build a model in terms of years. You probably also don't build it in terms of seconds. Minutes is probably appropriate. Additionally, you have to then think about for the individual interactions that happen within the model, what's the smallest time segment that I have to take into account to make sure that I don't miss any relevant interactions. Now, that while the first one, the, the, the time units are typically relatively easy to determine, the time step is usually a bit more difficult. You and you usually end up determining it from a trial and learning scenario. So that if I set up, I mean, this is the adjusting the shower model that I've been using in a number of instances, where the behavior of this model is dependent upon the time delay and the action factor. So if I begin with a current current water temperature, which is cold, and the desired water temperature is, it's the temperature I want it to be, and I just go ahead and run the simulation. Notice that this is the desired water temperature. The current water temperature exceeds the desired water temperature, and then I have to adjust the faucet back the other way, and it oscillates a little bit. A lot of that has to do with how quickly, or the amount of impatience I have for not waiting for things to change. It also has to do with the fact that my simulation settings, my time step is 1. So I'm only looking at things every minute. So in this case, I should go ahead and try and see what happens if I look at everything, look at the interactions every 30 seconds. Notice that the curve smooths out quite a bit, though there's still some amount of choppiness to it. So I'll go ahead and set this to 0.25. You should always use um, negative powers of 2. In other words, 1, 0.5, 0.25, 0.125, 0.0, 125, just so that each one is a half. It just seems to work out better that way than using tenths or smaller divisions. So now that I'm using 0.25 and I run the simulation, notice that it's getting much smoother. So that's looking at things in 15-second increments is probably appropriate. Now if I go ahead and change this and make the time delay longer and do another simulation, I notice that it's still relatively continuous, even though with this kind of time delay, operating with this level of impatience, I'm never going to end up with the water temperature that I really want. But the idea is that you first think about your model in terms of the time frame over which your model is going to run. So I want to start at 0 and go for 20 periods, and the time period is minutes. And then the question is, what's the time step that I want to that I want to employ when I do this? You also want to be sure that you don't build models that confuse the the time periods. It's inappropriate to try and build a model on a period of years where there are things that happen in the model in a time period of seconds or minutes. It's just they're, they're inconsistent. You want to be within a couple of powers of 2 of having the same time frame, so that if I'm operating in minutes, I can do 0.25 minutes or 15 seconds or divide that in half again to get 0.125, which is 7.5 seconds, and I get the relative interactions. If I need something smaller than that, I probably should develop the model in a period of seconds as opposed to minutes. There's a there's a lot of trial and learning that happens in this arena, and after you do a few, it will become second nature. So um, don't let it slow you down. Just go ahead and do it, experiment with it, learn from it, and as I said, it will get better. And hope you found this informative, and I'll see you in the next segment. Bye.